Hey guys, welcome to our video on Boyle's Law. This is the relationship between volume and pressure. We've already seen the first gas law, which was Charles' law. That was the relationship between volume and temperature. So now we're going to see what happens with volume and pressure. So for your what you'll need your notes, your Unit 3 Section 2 packet, and a calculator. So we're going to look at the relationship between pressure and volume, and also calculate what happens when you change both of those. So we're going to take a look at the PhET simulation that we had seen before. Where is it? There we go. I'm going to keep temperature constant, and then we're going to see what happens with volume and pressure. So right now the pressure was 0 atm. I'm going to increase the pressure. All right. So the volume's staying pretty consistent. Let's see what happens to the pressure as I make this container smaller. I decrease that volume. Okay, notice that temperature is trying to stay pretty much the same, close to that 300. But look at the pressure. That's increasing. Okay, what happens when I make my volume bigger? I add more space to it. My pressure is decreasing. All right, so right now I'm about 0.5 atm. And that's for pressure. Then I'm going to decrease the volume. My pressure will increase. All right. So that was that little PhET simulation. I highly encourage you guys to go online just to take a look at it. So now we're going to look at the relationship between pressure and volume. This is called Boyle's law. So at constant temperature, meaning that temperature does not change, it stays the same. As the volume of the container decreases, the pressure increases. Right, so when that volume gets smaller, when the size of the container gets smaller, there's so much more pressure in there. There's so many of those particles bouncing off the walls and off of each other. Conversely, as the volume of the container increases, meaning the volume gets bigger, the container gets bigger, the pressure of the gas decreases. There's less movement of those particles. There's less collisions, with the sides of the containers as well. So pressure and volume are inversely proportional. And the way that we would show that would be P is proportional to the inverse of volume, or you might even see this symbol. It's pretty rare, but you can see that one as well. All right, so let's look at the next thing. So pressure times volume, so P1 times V1 is equal to the pressure, or the second pressure times the second volume. And take a look at the graph. Volume is on your x-axis, pressure is on your y-axis, and as the pressure goes down, as you increase the volume, the pressure goes down. So you actually see that it is going to be inversely proportional, but notice that it's a slope. It's not a straight line. This is pretty unique for Boyle, or for the gas laws that we'll see. Boyle's law is one of the ones that actually slope down, kind of like a roller coaster. So when we have, this is another image actually showing you from NASA, what ends up happening when we have a piston or a container. We keep temperature constant at 300 Kelvin. We don't change pressure, we don't change temperature. We're trying to change what happens with the volume and the pressure. So the volume is over here. So these are, a V1, and then over on the right is the V2. So the volume here is around 4, and they don't give any units, so I don't know what the units are here. Then the volume has decreased down to 3. And let's take a look at our pressure. It went from 1 to 1.33. So as volume went down, the pressure had gone up. So let's take a look at one of the problems. As usual, you need to make sure that you write down what your variables mean, or what they represent, on the left-hand side. Then we'll write down the formulas and rearrange our formulas. Then we'll finally plug in the values and have our final answer. So for number 2, a gas occupies 12.3 liters at a pressure of 40.0 millimeters of mercury. What is the volume when the pressure is increased to 60.0 millimeters of mercury? So let's take a look at our variables. So 12.3 liters means volume. Millimeters of mercury means pressure. That is something that you guys do need to know. So my first volume was 12.3 liters. My first pressure was 40.0 millimeters of mercury. Okay. Then we'll look at the next part of it. What is the volume? So I need to know what my new volume is. So this will be X I'm going to keep it in liters though, so make it X liters, when the pressure is increased to 60.0 millimeters of mercury. You have to watch out for me. I'm going to be pretty tricky. I'm going to change up some of these units on you, so make sure that you are aware of that. Here I have millimeters of mercury for P1. My P2 is also millimeters of mercury. Make sure it stays the same. If I have changed up the pressure units for you, make sure you go back and change those pressures to be the same units. Doesn't matter what it's in as long as they're both the same units. So let's go back to the formula. We know that we have P1 V1 is equal to P2 V2. So we're going to rearrange this equation so I get V2 all by itself. So I want V2 is equal to P1 V1 over P2. So I'll plug in my values. 40.0 millimeters of mercury. Put those units in there so we know that they cancel. Volume is 12.3 liters. That's over P2, which is 60.0 millimeters of mercury. And let's see what cancels. I have mmHg there, mmHg there. It's on the top. One's on the top, the other's on the bottom, so I can cancel them out. I'm left with liters, which is good because that's what I wanted over here. I'll plug this into my calculator. It's 40 times 12.3. Press the enter button, then the division button, so divide it by 60 millimeters of mercury. And then let's figure out how many sig figs we need. So this has 3 sig figs, this has 3 sig figs, and this has 3 sig figs. So our final answer will be in 3 sig figs. This ends up being 8.20, and then I know I have my unit liters. Good. So I have the correct values here. I have the proper rearranged equation, plugged in values, and then for my answer, I have the correct answer, the correct sig figs, the correct units, and a box around the answer, or a circle around the answer, whichever you prefer. Just make sure it's big and bold and I can see it. And also, make sure that your decimal point is also big and bold so I can see that. I'm getting older, guys. Alright, so for a quick summary, Boyle's law. It's dealing with pressure and volume. They're inversely proportional, so you actually end up multiplying P1 times V1 is equal to P2 times V2. The P stands for pressure, the V stands for volume, the 1 stands for the initial conditions, the 2 stands for the changed conditions. And then the graph itself, you have P on the y-axis, V on the x-axis, and it curves down and slopes. Right? So let me know if you guys have any questions. Take care. Bye.